Now let's take two more examples on turning point. First, we were given y is equals to 4 theta plus exponential minus theta. Y is equals to 4 theta plus exponential minus theta. Remember the first step? Step 1 is to evaluate the y dx. But in this case, our variable is theta. So we are going to evaluate the y, the theta. And this will give us 4 minus exponential minus theta. The next step, step 2, is to set the y the theta to be equals to 0. Therefore, we have 4 minus exponential minus theta to be equals to 0. Therefore, 4 is equals to exponential minus theta. Now, we recall that 1 over x raised to power n is equals to x raised to power minus n from the law of indices. Therefore, 4 is equal to 1 over exponential theta. Henceforth, we can say exponential theta is equals to 1 over 4. Now, let's take natural logarithm of both sides. Natural logarithm, natural logarithm. Natural logarithm will nullify the effect of exponential. Therefore, theta is ln natural logarithm of 1 over 4. And this is equal to minus 1.3863. So when the theta is equals to 0, our value of theta is minus 1.3863. Let's move to step 3. In step 3, we are asked to evaluate the coordinate value of y. Recall that y from the question is 4 theta plus exponential minus theta. So when we substitute the value of theta to be equal to 1.3863, our y is equals to 4 into minus 1.3863 plus exponential minus into minus 1.3863. And this will give us minus 1.5452. Therefore, our coordinate of the turning point is given as minus 1.3863, minus 1.5452. This is the coordinate of the turning point. And finally, in step 4, we are going to determine the nature. And we recall that if the square y, the x squared, now in this case we are using theta. So we can say if the square y, the theta squared, is greater than 0, the point signifies a minimum point. And if the square y, the theta squared, is less than 0, the point signifies a maximum point. And if the square y, the theta squared, is equal to 0, the point signifies that of inflection. Therefore, let's evaluate the square y, the theta squared. But first, we have to know what is the y, the theta. And the y, the theta as evaluated is 4 minus exponential minus theta. 4 minus exponential minus theta. Now, let's evaluate the square y, the theta squared. And evaluating that, we will have minus into minus exponential minus theta. And this will give us exponential minus theta. Now, since the coordinates we are having is this, therefore we say for minus 1.3863, comma minus 1.5452, the square y, the theta squared at theta is equal to minus 1.3863. Now I want to determine the nature, if it is a maximum, minimum, or point of inflection. Is exponential minus into minus 1.3863. And this is going to give us 4.0. And this is greater than 0. And if it is greater than 0, we have that this point is a minimum point. So we have been able to determine the nature of the curve. In the second question, that says y is equals to 8 plus 2x minus x squared. Number 2, y is equals to 8 plus 2x minus x squared. You can pause the video now and try to solve this yourself. Alright. Step 1. For step 1, we are asked to evaluate the y, the x. And the y, the x in this case is 2 minus 2x. In step 2, we are required to evaluate value of x at the y, the x is equals to 0. Therefore, 2 minus 2x is equal to 0. 2 is equals to 2x. Therefore, x is equals to 1. In step 3, we are required to evaluate the value of y at x is equals to 1. Therefore, when x is equals to 1, we substitute the value of 1 into y. That's 8 plus 2 into 1 minus 1 squared. And this will give us 9. Therefore, the coordinate of the turning point is 1, 9. Now with this done, let's determine the nature by evaluating the square y, the x squared. Since the y, the x is 2 minus 2x, the square y, the x squared is minus 2. Now we can see that minus 2 is less than 0. And if it is less than 0, we have that the point is a maximum point. The y, the x less than 0, hence 1, 9 is a maximum point. Now we have been able to evaluate and determine the nature of curves, the turning point, and the nature, whether it is a minimum point or a maximum point. In our next video, we'll be taking a look at tangents and normals. Tangents and normals.